This is sample problem 10.12. A 1.00 liter vessel, a container, contains 0.215 moles of N2 gas and 0.0118 moles of H2 gas at 25.5 degrees Celsius. Determine the partial pressure of each component and the total pressure in the vessel, in the container. Okay, this is one of those partial pressure type problems. It's Dalton's law of partial pressure. So they ask us to find the pressure of each gas. When they say partial pressure, they mean what is the pressure of a gas that is in a mixture of gases. So in this problem, there are two gases. There's nitrogen and there's hydrogen. Each individual pressure is called the partial pressure. Before we go through the calculation, we'll point out that Dalton's law of partial pressure says that the total pressure of a mixture of gases is the sum of the individual pressures. So for two gases like nitrogen and hydrogen, all we do is add those two pressures to get the total pressure. For the ideal gas law, or I should say for the properties of gases, this is a nice thing because what it says is if you have mixtures and you want to figure out what the total property of this is, in the case of pressure here, that's a property of the materials of the mixture. It's very simple. You just figure out each one separately and then add them together. Very nice. So we'll just go through it using the ideal gas law. P of nitrogen would be N of nitrogen RT over V. Right? I've taken the ideal gas law, PV equals nRT, divided both sides by V to get P. And we'll do the same thing for the hydrogen. The pressure of hydrogen would be the moles of hydrogen times RT over V. They're in the same container, so they're both going to have the same temperature and volume, but the number of moles could be different, and in fact they are. So let's do nitrogen first. Nitrogen is 0.215. Oops. It's R, right? So that's 0.08206. And then the temperature is 298.65. How did I know that? I took 273.15 and I added it to the temperature in Celsius, 25.5. So if you add those together, you get 298.65. Okay, what's the volume? The volume is 1 liter. Oh, that's nice. That makes the arithmetic easy, right? It's always nice when one of the variables or one of the properties is 1. It's even nicer when two of them are 1. Okay, what about for the hydrogen? nRT over V, right? So for N, it's smaller, 0.0118 moles. Times the R constant, 0.8206. And it's in the same container, so it's going to be at the same temperature, same vessel. And 1 liter. Okay. The dimensional analysis, you can go through that yourself, will show that the partial pressures are in atmospheres. Okay, so let's go ahead and do the nitrogen. It is 298.65 Kelvin and 0.215 moles. Oops. Let's clear that. 0.215 moles times 0.08206 times 298.65 over 1. 5.27 atmospheres. Let's do the hydrogen. The only thing that's different is it's 0.0118 moles. Again, we don't need to divide it by 1. 0.289. See how much lower the pressure of hydrogen is? Even though they're the same temperature and same volume, there's a lot fewer moles of hydrogen. What determines this pressure is the number of moles. So the more moles you have, the higher the pressure. So now we have the partial pressures. Let's find our total pressure. You just add them up. So 5.557, let's go ahead and round that to 5.56. So the terminology is the partial pressure of nitrogen is 5.27 atmospheres. The partial pressure of hydrogen is 0.289 atmospheres. And the total pressure is 5.56 atmospheres. Dalton's law of partial pressures.